Today we are going to be looking at writing equations of lines in slope-intercept form, which we already have learned some methods that we can do that, but we're going to take this a little bit further today. And what we're going to look at is the idea that we can turn anything in point-slope form into slope-intercept form by solving for y. So if we were to get an equation like y minus 4 equals 3 times x plus 9, right? We already plugged that into point-slope form. We can then solve this for y to turn it into slope-intercept form. So to solve this for y, probably when we look at this, one of the first thing that jumps out at us is we see parentheses, so it'd be a good idea to distribute. Okay, so we're going to take that m sitting in front of the parentheses and we're going to pass it out to both numbers inside the parentheses, right? When we distribute, we multiply. So 3 times x gives us 3x, and 3 times 9 gives us a 27. We still have y minus 4 on the other side. If we want to get y by itself, right? So we're looking on the y side, we want this alone, we're going to have to move this 4. Okay, so we undo subtraction with addition. So our second step is going to be to add or subtract the number with y. Okay, so I'm going to add 4, and I'm going to add that not underneath the x because 4 isn't a like term with 3x, but it's a like term with 27. So I'm going to add it over here. So that is going to give me, those cancel, y equals 3x plus 31. Okay, so when we're here, right, we now have something in slope-intercept form. And often then the question is, well, why are we even doing that? What's the point? So there is a really important reason of why we do this. So that's what we're going to sort of look at next. So we're going to write the equation of a line that has a slope of -2 that passes through the point 1 comma -6. So just plugging this into point slope form. So if I do that, I'm going to say y minus my y coordinate, which is -6, equals m, which is my slope, times x minus my x coordinate, which is 1. Right, and we know that those two negatives make a positive, and so I have y plus 6 equals -2 times x minus 1. That is the equation of the line. That's where we would have stopped yesterday. Okay, and if we look at this one over here on the right, okay, let's write the equation of the line with this information. So we're going to say y minus our y coordinate, which is 6, right? That's our x sub 1 and y sub 1, equals our slope, which is -2, times x minus our x coordinate, which is -5. And we also know that these two negatives make a positive, right? So we have these two separate equations happening here. Now, if we say, okay, well, let's solve these for y. So let's go through these steps we just talked about and let's turn this from point slope form into slope-intercept form. So the first thing that we would do is we're going to distribute this -2. So -2 times x gives us a -2x. Now we have to be careful here when we distribute because -2 times -1 gives us a positive 2. So we'll have y plus 6 equals a -2x plus 2. Okay, then we're going to add or subtract to move the number sitting over here with the y. So we're adding a 6, so we're going to undo addition by subtracting a 6. And we're going to put that with our constant over here. So those 6's cancel, and we'll get y equals a -2x minus 4. Okay, so there it is in slope-intercept form. So let's do the same thing for our equation over here on the right. So the first thing we're going to do is distribute. So -2 times x gives us a -2x. And -2 times, now a positive 5, right? Because those two negatives made a positive, gives us a -10. We'll undo subtracting 6 by adding 6. And we'll get y equals a -2x minus 4. Okay, so what do we notice about these two equations? Well, these two equations are exactly the same line, right? They are the same. And when we look at them in slope-intercept form, it's obvious that they're the same. But when we look at them in point-slope form, they don't look the same. Okay, so the reason or why we solve this for y is so that we can recognize if we are talking about the same line. So it is now going to be the expectation that if we have something in point slope form that we are always going to solve this for y. right? Directions are not if we say, write the equation of a line and you end up with something in point slope form, you better solve it for y. It's just going to be understood. Okay, now there is one new piece that we can add today other than just solving. Okay, we can also write the equation of a line if we are given 2 points, and we haven't looked at doing that yet. And the reality is you know all the information that you need to know to be able to write the equation of this line. We just now need to put them together. Okay, so to write the equation of a line in point slope form, we need a point and we need a slope. And when we are just given these 2 points, right, we don't know what the slope is. But the good news is that we know how to find the slope, right? We know that we have this formula, y2 minus y1 over x2 minus x1. And so we can find the slope. So that's going to be the first thing that we do. So we're going to take -6 minus -9 over 2 minus -4. Okay, and on the top, we're going to get a 3. And on the bottom, we're going to get a 6. We know we have to get this in its simplest form. So this tells us that our slope is now 1/2. M equals 1/2. Well, to write the equation of a line in this form, we need a point and a slope. So we have a slope. So now we're going to pick a point. The good news is that we have 2 points. Okay, and we just need to pick one of them. So you can pick whichever one is your favorite because it has your favorite number, because it avoids negatives, because it's smaller numbers. I think I'm going to pick 2 common -6 because they're slightly smaller. Okay, so I'm going to pick the point 2 common -6. And then I'm going to use this information to do exactly what we did yesterday. We're going to plug this into point slope form. So we are going to say y minus y sub 1, right? Our y coordinate, which is going to be -6, equals m, which is our slope, times x minus 2. And while we would have stopped there yesterday, today we now know that we want to solve this for y. Okay, so we know these 2 negatives become a positive. We are going to distribute. So 1/2 times x is 1/2 x. 1/2 times a -2 gives us a -1, right? We're taking half of 2. So now we have y plus 6 equals 1/2 x minus 1. We're going to subtract that 6 from both sides. And we will get y equals 1/2 x minus 7. Okay, so we're going to take all that information and just apply it to some different examples here of how we can take this info and use it in different situations. So this first one, we have our very straightforward basic info, right? Plug into point slope form, y minus -7 equals -4 times x minus 5. Again, it is the expectation that we are getting this into slope-intercept form. So we are going to distribute. A negative times a negative gives us a positive 20. We will undo adding 7 by subtracting 7. And so this will be y equals -4x plus 13. Okay, if we look at our second one, we are given 2 points, right? We can't write the equation of a line without its slope, so we need to find its slope first. And we can do that by using our slope formula. So we will do -6 minus 2 over -5 minus 5. Okay, so we'll have -8 over -10. That's not reduced. It's not in its simplest form. So 2 negatives make a positive, and we can simplify that to 4/5. So we have our m. So now we just need to pick a point. You could pick either. I think I'm going to pick the 5, 2 because it's slightly smaller numbers. And then we'll start plugging in. So y minus 2 equals 4/5 times x minus 5. If you're not comfortable with the larger fractions when you distribute, just use your calculator. So 4/5 times x is 4/5 x. 4/5 times a -5 will give us a -1. Oh, I lied, 4. Negative 4. Then we will undo subtracting 2 by adding 2. And so we'll have y equals 4/5 x. Now be careful when you're combining like terms here because this is a negative 4 plus 2, which will give us a negative 2. Now this same information applies to any way that we are given information. So maybe we're given a graph. Okay, we don't have a y-intercept, so we can't just find that m and b. Okay, so which means we need to go back to that point-slope form. So we need to find the slope. So slope is rise over run. So how many do we go up? We go up 1, 2, 3, 4. And we go over 1, 2, 3, 4, 5, 6. Now we went left, so that's a negative 6. So we have our rise over our run, which can be simplified to a negative 2/3. We also need to pick a point. So we can pick either of the points that are given to us, or we could pick another point on the line as long as it's a good point. You just have to make sure that you name it appropriately. So this right here is the point 5, 0, right? Our x value is 5, our y value is 0. So we can now plug this into point slope form. So we will say y minus our y coordinate, which is 0, equals negative 2/3 times x minus 5. Well, good news for us, a y minus 0, that's not even anything we have to move, so that just kind of goes away. But we do still need to distribute. Negative 2/3 times x is a negative 2/3 x. And a negative 2/3 times a negative 5 is a positive 10/3. Now, whether you want to change this 10/3 to a 3 1/3, same rules as we had before, you just cannot approximate. Your slope has to be reduced in proper fraction form. Your y-intercept cannot be approximated. We can do the same information if we are given a table. Okay, if we are given a table, in fact, we are given multiple points. And we know this gives us 4 points. So we need to find the slope, and then we need to plug into point slope form, right? Are we tired of using that same process yet? It's over and over and over and over and over this unit. So you can find the slope by just picking 2 points and seeing what you have to add. But for some of you who may have decided, you know what, that's just not my favorite way to do that. You can also just list them as ordered pairs, and then the problem just works out like it did directly above. So if we pick 2 points from here, you can pick any 2 points. I might lean towards picking these 2 points here because there's no negatives and the numbers are smaller. But that option is up to you. So we have the ordered pair 3, 1, and we have 5, 9. So to find the slope, I'll say 9 minus 1 over 5 minus 3. So 9 minus 1 gives us an 8, and 5 minus 3 gives us a 2. Okay, so we know that our m equals 4. We then need to pick a point. Maybe I choose to use that with 3, 1. So I'll say y minus my y coordinate is 1 equals m, which is my slope, that's 4, times x minus my x coordinate, which is 3. Okay, so we'll distribute. And then we will add to each side. So we have y equals 4x minus 11. Now we have one small sneaky thing on this one. This doesn't say x and y. This says x and f of x. So if we truly want to write this appropriately for this table, we need to change our y value to f of x instead and have it in function notation. And we would say f of x equals 4x minus 11. We look at our next one. Again, we have 2 points, so we're going to find the slope. 4 minus negative 12 over negative 8 minus negative 8. We will get 16 over 0. When we have 0 on the denominator, that tells us that our slope is undefined. Okay, and at this point, we should recognize that undefined slope is a vertical line. We cannot plug the word undefined in for m. right? We can't distribute the word undefined. We need to go directly to x equals, a vertical line. And what does our x coordinate equal? It equals -8. Now you might say, what if I pick the other point? Well, you only get undefined slope if your x values are the same. So our equation would be x equals -8. And then our last problem, okay, we're writing the equation of a line that's between those 2 points. So we need to find our slope first. So -1 minus -9 over -14 minus 22. So let's see, we will get 8 over 36, -36. And we can simplify that. So 4 will go into 8 twice. 4 will go into 36 9 times. And so we get a slope of -2 over 9. I think the point I'm going to pick is -14, -1. So I'll say y minus -1 equals -2/9 times x minus -14. And there are, holy cow, a lot of negatives to keep straight. But we know that these two turn into a positive, as do these two. We will distribute -2/9 x. Again, if you are not comfortable with the fraction at this point, there is no problem with saying, okay, I think I'd just better use my calculator and see what that gives me. Okay, so if you're typing this in, right, -2 ABC 9 times a positive 14, and we get -3 1/9. And then we will undo 1 by subtracting 1. So again, feel free to use your calculator. If you have that sign correct in your calculator, we have that -3 1/9, and we're going to subtract 1 off of it. And so we'll get a -4 1/9.